today we will be discussing about the case 6, which is rational functions containing even power of x. So we'll discuss about rational functions. If they have even power of x, then how are we gonna solve them into partial fractions? So we will let's see an example and work out it. Okay, so we'll say this example over x squared plus 1 times x squared plus 2. So like, if you guys are not aware of this case, generally what you would do is you would directly write this as x squared plus 1 plus x squared plus 2, and on the numerator you will be writing as ax plus b and cx plus d. This is of course perfectly correct. If you go in this way too, you will find the answers exactly right answer. But here you would have a lot of constants to find, and like, if you don't know this method, you will take extra few minutes, which might be costly in your examinations. So let's see how we are going to solve this when we have even powers of x on the numerator and in the denominator. And also be mindful that on the powers in the numerator is less than the power in the denominator. So when you have even powers, what we do is we just use a substitution. We put t equals x squared. So when you put t equals x squared, what do you get? You get t over t plus 1, t plus 2. Now we solve this as some basic partial fractions solving equations. So like, we write this as t plus 1 plus t plus 2. The numerator will be a and b. So now, like, we just solve it with t. So when you solve it with t, what you get? You take t plus 1 and t plus 2 as the denominator, so which would leave you with the sum, right? And then if you put, and like, if you solve it, you will get a equals -1 and b equals 2. All you have to do is put t equals -2, then t equals -1, and find this a and b. So finally you will be left with this. So after you found that, you have to write everything in terms of x. So this was your initial problem. So yeah, you replace t with x squared. So when you replace t with x squared, you get your final answer as this. Isn't this simple? Like, it just only took you maybe a minute or two. Like, if you had done it the other way, it would have at least taken you 5 minutes to solve. It's all about saving time, guys. Let's look into another example. Example 2. Let's see, x to the power 4 x squared plus 1 x squared minus 2. So here too, you take x squared equals t and try to solve this. So in that case, you will have t squared t minus 1 t minus 2. Always be mindful. In this case, if you look carefully, the powers in the numerator and the powers in the denominator are equal. So this relates to case number 5. If you are following my partial fraction series, so this relates to case number 5. So we write the partial fractions as a plus b over t minus 1 plus c over t minus 2. And then when you take the common denominators, you will be left out with 1 plus b times t minus 2 plus c times t minus 1. When you put t equals 2, you would get 2 squared equals t times 2 minus 1, we should actually leave c equals 4. Then what you do is you put t equals 1. When you put t equals 1, what would you get? You get 1 equals b times 1 minus 2. B equals minus 1. And then you put t equals 0. When you put t equals 0, you get 0 equals a minus 2, should leave a equals 1. So that's it. Now you write, like you have found all the constants. Now you write all the t's with x squared. So this is your problem. And when you put it into partial fractions, you get it as square minus 1 plus 4 over x squared minus 2. So this is the final answer. And always when you get the problem, don't just blindly go solving. Just look at the problem and try to categorize which case I could put this problem and solve. So every problem has a particular case. So if you can identify the case, then the solving wouldn't be difficult for you.
Thank you guys for watching the video. If you guys like the content that I do, give it a thumbs up and don't forget to subscribe. You also can follow me on the Instagram Maths4Me.